So throughout this unit, we solved systems of equations by linear combinations, which is elimination, by substitution, and by graphing. Then we got into this whole idea of matrices and learned that a matrix was a way for us to organize information, data, numbers, that type of stuff. Now we're combining those ideas. We're going to learn how to solve systems using matrices. So the first thing I want to take a look at here is we can rewrite a system with a matrix equation AX equals B. And each of those represent an entire matrix. So matrix A is the coefficient matrix. So we know a coefficient is the number in front of the variables. Our matrix X is going to be our variable. So that's our matrix of variables. And then the B is going to be our matrix of just the constants. The best way to remember this is just simply almost look at the system as being like your matrix A. So those coefficients, 5, 4, 2, and 3, would be your matrix A. Your matrix X would be the variables, an X and a Y in this case. Then our B is the constants. So it's almost like you look at that like it's a matrix. And we're getting 6, 1. Go ahead and do the same thing for B and C. So you have the coefficients, which make up your matrix A. You have the variables that make up matrix X. And then the constants are your matrix B. Go ahead and pause and take a look at those two. So with B, if I kind of look at them like this, I have 2, 3, 4, 2. It's my matrix A. The variables, X and Y, and then B would be just 4, 12. With the third one, the idea is exactly the same. You're just kind of looking at those numbers. Now, what number is in front of these X's? Those are 1s. So the coefficients would be 1, 1, -3. Then we have 1, -1, +2, 2, 1, and -1. Our X matrix would be our variables. In this case, X, Y, and Z. And then our B matrix would be this last part, -10, 3, -6. So AX equals B, and each of those represent an entire matrix. Looking at this one, what's meant by X? That's our variables matrix. Typically, that's going to be our X and Y, maybe our X, Y, Z. In this case, not sure what it would represent because we know in order to multiply a 2 by 2 and getting a 2 by 3, middles would have to match up. So I would need a 2 here. And then the outsides are what would give us that. So it would be a 2 by 3 matrix. So not sure what the variables would be, but we won't do any exactly like that. We typically do X and Y, X, Y, Z. Now, how do we solve? before we go into solving, I want you to think about a problem that you've done probably 100 times. If you had something like 2x is equal to 6, to solve for x, you divide both sides by 2 and you get x to be 3. Another way, instead of dividing by 2, you can multiply both sides by a half, and that'll do the exact same thing. When dealing with matrices, we can't divide matrices, but we can multiply. So here's what you do. When you have a system written out as ax equals b, to solve for x, you end up doing a inverse times b. So it's kind of like, in order to get this x all by itself, it's like dividing by a, but we can't do that with matrices. So we multiply by a inverse. And it's like these cancel out, so you're left with just x. And then here you have a inverse b. And it's important that it's a inverse times b. It's got to be on the left of the b. B times a inverse can give you something different. So if we take a look at one of these, to rewrite as a matrix and then solve. So rewriting, we think of -3, 4, 2, -1. Our matrix X would be like our X and Y, and then our B would be 5 and 10, -10. So A, X, B. If we're trying to solve for x, we have to do A inverse times B. So let's go to our calculator. We'll type in our matrix A and our matrix B, and then multiply them together with the inverse. Second matrix, arrow to the right to edit. I already have it set up as a 2 by 2, -3, 4, 2, -1. Second quit, just to go back to the blank screen. Matrix B is 5, -10, so second matrix, edit, B. I already have it as a 2 by 1 also. Change yours if you don't. 5, -10, enter. From the blank screen, now we want to tell it or name it A inverse times B. Second matrix, letter A, then the inverse key is the matrix key without the second, and then second matrix B. So you get something that looks like this. These keystrokes are the same on the actual TI-84 calculator. And we hit enter. And it turns out we get -7, -4. So our matrix X is -7, -4. Remember what our matrix X was, X and Y. So that's saying our X is -7 and our Y is -4. So back when we solved these with elimination, substitution, graphing, we would write the answer as -7, -4, and that's showing that that's where those two lines intersect. We're okay writing it as just a matrix. go ahead and take a look at these 4 practice problems. We're going to actually skip number 1. Those end up being the exact same lines, so you get like an error message in the calculator. That's one where you have infinitely many solutions. So it's a bad first practice problem for you to do on your own. Go ahead and do 2, 3, and 4. Set up the matrix equations, and then you do A inverse times B. Pause, and I'll go ahead and give you the answers. For number 2, you should be getting an answer of -2, 1, 3. That's our X, Y, and Z. For number 3, you should be getting 14, 34, and 20. Oh, I messed that up. You should be getting -6, 10, and 4. And then for number 4, you want to set those matrices up, and just to kind of give you a hint, you have Jill, Laura, and Mike. You have small, mediums, and larges. So maybe do a different L than the one I had there. Your matrix would initially look like this. Your matrix X would have been your smalls, mediums, and larges. And then those total costs were 164, 178, and 126. So when you do solve A inverse times B for this one, you get 8, 10, and 14. So what that's saying is small pizzas cost $8, mediums cost 10, and larges cost 14. Hope that helps. Hit me up with any questions if you have them. See you soon.